Learn English with Wikipedia. Turn on and select subtitles to see the keywords translated to your language. A black hole is a region of space-time from which nothing, not even light, can escape. According to the general theory of relativity, it starts existing when space-time gets curved by a huge mass. There is a sphere around the black hole. If something goes inside the sphere, it cannot leave. This sphere is called the event horizon. A black hole is black because it absorbs all the light that hits it. It reflects nothing, just like a perfect black body in thermodynamics. Under quantum mechanics, black holes have a temperature and emit Hawking radiation, which makes them slowly get smaller. Because black holes are very hard to see, people find them by the way they affect other things near them. The place where there is a black hole can be found by tracking the movement of stars that orbit somewhere in space. Or people can find it when gas falls into a black hole, because the gas heats up and is very bright. This can be found by telescopes on Earth or by Earth-orbiting telescopes such as Chandra or XMM Newton. Inside a black hole, the rules of physics are very different. Astronomers have found evidence of supermassive black holes at the center of almost all galaxies. In 2008, astronomers found evidence that a supermassive black hole of more than 4 million solar masses is near the Sagittarius A** part of the Milky Way galaxy. Formation of black holes. The gravitational collapse of huge stars cause stellar mass, black holes. This happens when really massive stars run out of fuel. Star formation in the early universe may have created very big stars. These stars were so large that their cores collapsed into black holes. The black hole at the center of these stars slowly consumed the star from within, making black holes of up to 103 solar masses. These black holes may be the seeds of the supermassive black holes found in the centers of most galaxies. If these stars really existed, they may even explain where supermassive black holes come from. Most of the energy released in gravitational collapse is given off very quickly. A distant observer sees the material falling in slowly and then stop just above the event horizon because of gravitational time dilation. The light given off just before the event horizon is delayed an infinite amount of time. So the observer never sees the formation of the event horizon. Instead, the collapsing material seems to become dimmer and increasingly red-shifted, eventually fading away. Supermassive black holes. Black holes have also been found in the middle of almost every galaxy in the known universe. These are called supermassive black holes and are the biggest black holes of all. They formed when the universe was very young and also helped to form all the galaxies. Quasars are believed to be powered by gravity collecting material into supermassive black holes in the centers of distant galaxies. Light cannot escape the SBHs at the center of quasars, so the escaping energy is made outside the event horizon by gravitational stresses and immense friction on the incoming material. Huge central masses have been measured in quasars. Several dozen nearby large galaxies, with no sign of a quasar nucleus, have a similar central black hole in their nuclei. Therefore, it is thought that all large galaxies have one, but only a small fraction are active, with enough accretion to power radiation, and so are seen as quasars. Properties of black holes. The no-hair theorem basically says that once a black hole has formed, it only has three physical properties that we can measure: mass, charge, and spin. If this is true, then if two black holes had the same mass, charge, and spin, then they will look the same. As of 2020, it is unclear if the no-hair theorem is true for real black holes. The properties are special because all of them can be measured from outside the black hole. For example, a charged black hole repels other like charges just like any other charged object. Similarly, the total mass inside a sphere containing a black hole can be found by using the gravitational analog of Gauss's law, far away from the black hole. The angular momentum or spin can also be measured from far away. When anything falls into a black hole, any property that isn't part of the three properties of a black hole, like shape or charge distribution, gets erased and can't be seen from outside. This is a very big problem because we lose a lot of information about what went into the black hole, including certain quantum properties, and physics tells us that information cannot be destroyed. This puzzle is called the black hole information loss paradox.